In this video, we're going to learn how to use Analyze Toolpack under Data tab to answer to other questions from A through H. And we're going to skip all the calculation that is done by hand. So the question here in this problem, we have a vendor in a farm stand is pretending that it can predict the weight of the pumpkins just by knowing the circumference of the pumpkin. So we wanna determine whether this assumption is true or not. So we collected 23 pumpkins, we determined their results, their weights, and we get the results over here. All right, and then we're gonna get the equation or the predictive equation and we place it over here, right? So the first thing to do is to get the data, and once you click on the data, this is the scatter plot that we have here. So obviously there is a linear regression, all right, on the scatter plot. But again, let's download the data and determine the B0 and B1. So first of all, you click on the double window there, open in Excel, download it, open it. All right, so once you upload the file, make sure to enable the editing. And what you want to do, you want to go to the data and then data analysis. But again, let me emphasize that the circumference here, the circumference it will be the axis and the weight is going to be the y. All right. Okay, so once you go to under the data table, you go to data analysis and you select on the new window regression, which should be all the way in the end. Okay, and then we're gonna select the y range, and the y range will say is the weight, right? So I'm gonna select the label as well and select all the way to the bottom. And for the x inputs, we're gonna do similarly. So we can double click as well, and we get the circumference over here. So the weight is in gram unit and the circumference in centimeters. And then we're gonna select the label. We're gonna select the output range, and usually we're gonna put the output near over here on the same worksheet. All right, for the moment, that's all what I need. Say okay. I get the data. You can double click on the top all the way between the two cells, and this will expand all the numbers. So you're going to be more visible for you. All right. So now I need to identify the B1 and the B0. So the B0 will be right here. That's the intercept. Let me write it down here. B0. And the B1 would be this number over here. So let's change the color. And that would be the circumference, B1. There you go. So that's all what you're gonna do right now. So you're gonna go to your problem. So basically you have your y, I, is gonna be equals to B0 plus B1 x I. All right. So for this instance, the B0 is right here in yellow, and in red is the B1. All right. So let's go to problem. So the first variable you can be the B0. You can just click on it, copy it, and paste it over here. You want to round it to 1 decimal place, so you're going to be 0.27. That's you're going to turn into 0.3. Copy and then paste it over here, and you want to round to 1 decimal. So 27, that's going to be 3. Check it. Good. Now, it's asking you what the meaning of the slope. right? So the meaning of the slope is whenever you do 1 unit on the x values, the total, the y values, you're gonna change by b1 value, right? So, and this is the best choice whenever the slope indicate that for each 1 gram increases, that's mean, no, it's not, it's supposed to be centimeters, that the x value. So the slope indicates that for each 1 centimeter increases in a pumpkin circumference, the predicted weight in grams is estimated to increase by the value of B1. So every increase in the X is reflected on the Y's. Check it, good. Now they're asking you to predict the value for Y1, which is at X equals to 55 inches in circumference. And I think they made a typo here, mistake. They are giving you inches, the table is giving you centimeters, so I'm gonna assume it's centimeters. All right, so for this purpose I'm gonna create a table. So I'm gonna do a calculator here. So I'm gonna create my own calculator on Excel. In the first cell I'm gonna put the X values, and here I'm gonna put the Y values. So I'm gonna leave it empty for the first beginning. Well, I know it's 55. Let's put it 55. And over here, I'm going to use a function mode. So you're going to be equal sign. And I'm going to click on B0 first. So B0 will be this value. Then plus. I'm going to click on B1. And then multiplied by the cell X, which is 55. Enter. This should be my value, right? So let me plug it in, and you want to round it to 1 decimal place. So it can be 0.9. That's going to turn into a whole number. So 0 there, instead of 5. All right, let's double check it again. Right, it's good. So now, so is it good that the farmer to sell pumpkin by circumference instead of weights? And really is depending on the r squared. So you want to verify the r squared is really close to 1. So if it is close to 1, you should go and say yes. All right. If it is not really close to 1, so you're gonna say no. So this one, yes. All right. And the scatter plot here shows a strong positive association. So why did I choose strong positive? I didn't do the scatter plot, but it was done here. And you see it's really linear and positive going upward. All right. Okay, let's check. Great. Now they are asking about the r squared and what the definition of the r squared. So the r squared, again, if the value is 0.9444, and that is the average or the percentage, all right, that the percentage of the y's explained by the x's. All right, so the y value that I have is the weight. So the r squared is the proportion variation in circumference here. That's not what I need. So I need similar statement. Is the proportion of the variation in the weight here, that the y value is explained by the variation in circumference. So this is what will be my preferred choice. And here I'm gonna just plug in the value of r squared, and that's going to be 0.9444. And I think they want the r squared rounded to 3 decimal places. So here it might be a problem if you round to 4. So 0.944 should be fine. Check it. Fantastic. All right, so now the residual plot. All right, so what is a residual plot? So let's look for residual plot. So what I'm going to do, I'm going to just go to data again, go to data analysis, the same thing. I'm going to do the regression. Okay. So it's the same table, don't change anything. And you're just going to click on the residual plot here. So this is going to add to this data a residual plot. Say okay. So he can never override, say okay, it's fine. And we get this residual plot. You could extend it so you can see it better. And that's what we want, right? So we don't want any patterns. We want them more or less around this line. So this is a good residual plot for a linear regression. For question F, the answer should be the residual plot shows a non-linear pattern and clearly an equal spread. Plotting the residual in collection order is not necessarily a normal probability plot of the residual suggested that residual are roughly normally distributed. So for the question G at the level of 0.5 level of significance, we want to figure out the hypothesis testing. So what hypothesis testing we are talking about? We are testing whether the B1, which is the slope, is it 0 or not. So what's the problem with the 0? If the slope is going to be 0, we're going to have a horizontal regression. So although if we get perfect regression here, all right, perfect points on the points on the line, this is no regression. Regression, it cannot be horizontal. It always needs to have a slope. So if the B1 is 0, this is no regression, no good for me. So this is always the hypothesis. So H0 is always B1 equals to 0, and H1 is always B1 different than 0. So if what we want to get the result, as a matter of fact, we want to get the B1 different than 0. So there is a linear relationship, and here there is a regression. Otherwise, if the B1 is equal to 0, there is no regression, and even with the perfect coefficient of determination, the model is useless. Now, for this purpose, we use the t distribution. This is one of the tests that the Excel will do for you. And here they are the formulas. We are not going to use them at all. So you can find them on Excel. You can find the values. Excel give you the exact values right away. So the only thing to do is to verify whether you're gonna be accept or reject. And obviously we don't want to be here. We want to be within the rejection zone. All right, we want to be here. All right, this is H1 and this is H1. H1 is good for regression, and H0 is in the middle, is bad for regression. Right, so let's go ahead and identify the variables on Excel. So for this question, we already identified the variables. So you're going to be always B1 here, B1, that's the issue. And for the H0, you're going to be equals to 0. So you can type it in. And for this one, you're going to be different than 0. And again, type it in. Okay. So check it. All right. Nice. Now they are asking you about the t statistics. And just you have to identify the zone of this test. And that's this table, the highlighted table. We don't really need anything else. And as you notice here, we have two t-stat. The first one in this, we have the first one is this one for the intercepts, and we don't need it. We need the one for the circumference, that the B1. Copy it, plug it in, and you want to round to 2 decimal places, so that's going to be 90 here instead of 89. Let's check. Quite good. Now they are asking for the p-value, and the p-value, you can see it next to it. Or this p-value is basically 0, right? Why? Because we have e to the minus 14. It means this decimal is gonna be moved 14 position up front, all right, to the left, and that's gonna give me a 0. So e to the minus 14 is 0. So here I'm gonna type in 0, 0.000, and that's actually what we want, right? So we're gonna make a decision about this. So check, great, and now we're gonna make a decision. So probably it would be useful to go and explain it again on the chart. Okay, so either you're gonna use one of these formulas. So here the p-value, whenever is less than the alpha value, all right, you're gonna reject 80. So this is a good formula. So for our scenario, we have this is 0.000, and the alpha is gonna be 0.05, and that is correct. So our result is gonna be reject the 80. So what the meaning of this? So the alpha, as you know, because it's two tails, it's gonna be split in two. Over here, this is alpha over 2 is 0.025, and this is the other alpha over 2, right? And this separation is gonna be called the critical value, right? We don't need it because we are not using it. We're gonna use the p-value method. However, this is the threshold where you can start rejecting 80. All right, so now if I graph my p-value is 0. So what does mean 0? Is really far away, somewhere here. So that's tail is gonna be 0 technically, right? So again, this is gonna be p-value. Whenever we have two tails, we divide by 2. Well, it's 0, all right? But this is the location of the t dot. And as you notice here, is within the rejection zone, all right? I know it doesn't matter it's positive or negative, all right? Both of them, they are within the rejection zone, right? Okay, so that's what you are supposed to write down. Here the t stat, it was positive, so it was on the right side. So here we are rejecting 80, and whenever we reject, there is a regression. There is sufficient evidence for a linear regression, all right, or linear relationship. All right, the next question is asking you about the confidence interval, the 95 percentile. And this is already given to you by Excel automatically. And you can notice here the upper and the lower, the upper boundary and the lower boundary. So this we are talking about B1. The lower boundary is going to be this value. You can plug it in, and you want to round it to 3 decimal places, so you're going to be 2223, and this should be your upper boundary, and this is going to be that value around the 3 decimal places, and all set. Okay, let's check it. Right, and that's all set.